What if the light we have trusted for a century is whispering a lie? For generations, we have looked up at the night sky and seen a story of clockwork precision, a universe born in a singular flash, expanding outward with a predictable rhythm that we thought we had finally mastered. We built our greatest monuments of glass and gold, like the James Webb Space Telescope, to confirm the elegant math of our ancestors. We expected to see the faint, chaotic embers of the first stars. Instead, we found a reality that refuses to behave. When the first images from Webb reached our screens, the towering spires of the cosmic cliffs, the glittering tapestries of the deep fields, the world gasped at their beauty. But behind that splendor, in the cold, hard numbers of the data, a quiet panic began to set in among the architects of our cosmic understanding. The universe we saw was not the one the textbooks promised. It was too bright, too mature, and far too complex for its age. This is not a simple matter of a smudge on a lens or a decimal point out of place. It is a full-blown crisis in the foundation of everything we thought we knew. Nobel laureate Adam Riess, a man who dedicated his life to measuring the pulse of the cosmos, has issued a warning that is echoing through the halls of every major observatory. He suggests that the discrepancy in how our universe expands is not a human error, but a fundamental message from the fabric of space itself. The James Webb Space Telescope was designed to be the ultimate validator of our standard model. It was meant to provide the final signatures on a theory that has stood firm for decades. Instead, it has become a grand inquisitor, pointing its infrared eye at the cosmic dawn and showing us exactly where our logic breaks down. We are standing at the threshold of a scientific revolution, forced to confront the unsettling possibility that the laws of physics we observe today might have been entirely different when the stars were young. We set out to find the beginning of time, only to discover that we may have fundamentally misunderstood the very nature of the universe we call home. The silence of the deep universe is deceptive. Behind the majestic spirals and the glowing nebulae lies a mathematical ghost that has begun to haunt the very heart of physics. We call it the Hubble tension, but that clinical term masks a terrifying reality. The universe is defying its own history. We have two maps of reality, both drawn with the most sophisticated instruments humanity has ever conceived, and yet they no longer point to the same destination. On one side, we have the Planck satellite, peering at the ancient embers of the Big Bang. Its data is pristine, suggesting a universe that expands with a predictable, measured grace. But on the other side, looking at the stars in our own celestial backyard, the show's team found a different universe, one that is racing away from us with an unexplained, feverish speed. For years, skeptics clung to the hope of human error. They blamed stellar crowding, the idea that Hubble's view was simply too blurred to see the true distance of the stars. They hoped that once we had a sharper eye, the mystery would evaporate. Webb was that eye. It turned its golden mirrors toward those distant beacons with a clarity that borders on the divine. It didn't just confirm the old measurements, it sharpened the blade. The discrepancy is no longer a debate. It is a 5 sigma crisis. Mathematically, the odds of this being a fluke are now 1 in 3.5 million. The data is unrelenting. The cosmic clock is broken. We are forced to confront a chilling possibility: that space itself has changed its rules since the dawn of time, and the universe we thought we understood is a stranger we are meeting for the first time. The telescope did not just see farther. It saw what was supposed to be impossible. In the deepest, darkest corners of the infrared sky, Webb found ghosts that have no right to haunt the dawn of time. We call them the universe breakers. 6 massive galaxies, as sprawling and mature as our own Milky Way. Yet, they exist in a period when the universe was a mere infant, barely 500 million years old. According to every law of physics we hold dear, these structures should be small, chaotic clumps of gas, the fragile seeds of things to come. Instead, we found fully grown oak trees in a field where we had only just scattered the acorns. These celestial titans grew 20 times faster than the speed limit of the cosmos allowed. They defy the very skeleton of dark matter that we thought dictated the rhythm of all creation. Among them sits an anomaly we call the cliff, a massive red monolith of stars that mocks our evolutionary models. And the Big Wheel, a spiral galaxy so perfect and ancient, it appears to have stepped out of a future that should not have existed for billions of years. To find such order in the heart of primordial chaos is a shock to the scientific soul. But the mystery deepens into something even more radical. Scattered across these deep fields are the little red dots, mysterious, concentrated points of light that defy classification. Some researchers, desperate to save our standard theories, propose a terrifying alternative. These are not galaxies at all. They might be black hole stars, gargantuan spheres of primordial gas, millions of times the size of our sun, powered not by the gentle hum of fusion, but by the ravenous hunger of infant supermassive black holes, nesting within their hearts. If this is true, the early universe was not a quiet nursery. It was a theater of giants, a reality governed by forces we are only beginning to name. We are not just looking at the past, we are looking at a version of history that was never written in our books. To save the sanctuary of our standard model, we are now forced to entertain ideas that only a few years ago would have been dismissed as the fever dreams of science fiction. The data from Webb has pushed us into a corner where the only way out is to rethink the very ingredients of the cosmic soup. One leading contender is a ghost in the machine known as early dark energy. Imagine a fleeting, violent surge of anti-gravitational force that flickered into existence just after the Big Bang, only to vanish as quickly as it appeared. This momentary pulse would have acted like a cosmic bellows, stoking the fires of expansion and thickening the invisible skeleton of dark matter. It provides a narrow window, a way for those impossible galaxies to form in the blink of a celestial eye, while simultaneously explaining why the universe today appears to be racing away from us faster than our oldest maps predicted. But for some, adjusting the speed of the clock is not enough. They suggest we must double the length of time itself. Professor Rajendra Gupta has presented a controversial model that dares to suggest our universe is not 13.8, but 26.7 billion years old. He resurrects the tired light theory, proposing that light loses energy as it travels across the vastness of the void, and that the physical constants we once believed were eternal are, in fact, evolving. In this older, more patient universe, the universe breakers finally have the time they need to grow. It is a radical revision that offers a comfortable maturity to the cosmos, yet it requires us to abandon the very foundations of how we measure the passage of existence. And then there is the most profound challenge of all, whispered by Nobel laureate Roger Penrose. He looks at these impossible structures and sees not a beginning, but a bridge. In his vision of a cyclical universe, our Big Bang was not the start of everything, but merely the latest bounce in an infinite series of aeons. These massive, ancient galaxies might be the scarred survivors of a previous reality, relics of a universe that lived and died before our own was ever born. We are no longer just debating the age of our world. We are questioning if we are merely one chapter in a book that has no beginning and no end. These theories are the desperate, brilliant reach of a species trying to make sense of a reality that has suddenly outgrown its own definitions. If our maps are failing us, perhaps the only way to find the truth is to cross the ocean ourselves. We are no longer content to merely watch the light of distant worlds. We are preparing to touch them. Standing on the shores of our own world, we see the rise of a new breed of Leviathan, the SpaceX Starship. This is not merely a feat of engineering. It is a desperate, steel-clad prayer cast into the void. While Webb peers through the infrared veil, Starship is being forged to carry our curiosity into the very heart of the mystery. It is the vessel of an era where the word impossible is being deleted from our lexicon. Our gaze is fixed on worlds that shouldn't exist, orbiting stars that defy our age-old timelines. We look toward K2-18b, a Hycean world floating in the cold velvet of space. Webb has already sniffed its atmosphere, detecting signatures that hint at a liquid ocean and perhaps the chemical whispers of life itself. If the universe is indeed twice as old as we believed, or if it is a survivor of a previous cycle, then the history of life is not a brief spark, but a vast, ancient fire. We are looking for our inheritance among the stars. The colonization of the deep is no longer a dream of the distant future. It is an urgent necessity of the present. As we realize that we occupy a universe much stranger and more volatile than we imagined, the drive to become a multiplanetary species becomes a race against cosmic uncertainty. We are building the ships that will take us to these habitable exoplanets, not knowing if we will find gardens or graveyards. We are the first generation to know that our cosmic home is a mystery, and we may be the last generation to stay bound to the cradle of Earth. We are stepping into the dark, armed with golden mirrors and steel towers, ready to claim our place in a reality that is far more terrifying and far more beautiful than we ever dared to hope. We are witnessing the slow, majestic crumbling of a cathedral we have spent a century building. The Lambda CDM model, the bedrock of our modern cosmology, is no longer a fortress. It is a ruin, its walls breached by the very light it was meant to contain. But in the history of the human spirit, there is no shame in being wrong. Indeed, the most profound moments of our species have occurred not when we found the answers we expected, but when the universe had the audacity to surprise us. We are standing at the edge of a new enlightenment, where the breakdown of our theories is not a failure of intelligence, but an invitation to a deeper truth. For a long time, we viewed science as a collection of cold, static facts, an accumulation of knowledge that would eventually lead to a final, perfect period at the end of the sentence of existence. But Webb has reminded us that science is a living, breathing conversation with the infinite. It is a process of shedding our arrogance, a recognition that the outliers and the anomalies are not errors to be corrected, but breadcrumbs leading us toward a reality we have yet to name. Our legacy as a species will not be defined by the models we got right, but by the courage we showed when they fell apart. To look up at the stars and realize we are wrong is a humbling, exquisite form of progress. It is the sane humility felt by those who first realized the Earth was not the center of the world, or that the sun was but one star among billions. We are once again small, once again beginners in a vast, unfolding story. This crisis in cosmology is, in fact, a gift. It is the universe pulling back the curtain, showing us that the mystery is far greater, far stranger, and far more beautiful than our narrow imagination could ever have dreamed. We are the witnesses to a revolution, the first to see the cracks in the sky, through which a new understanding will eventually shine. We stand at a crossroads, where the light of the most distant stars has burned away our old certainties. The golden mirrors of the James Webb Space Telescope have done more than just reveal the past. They have challenged our right to claim the future. We thought we were the masters of the cosmic clock, the final editors of the story of creation. Yet the universe remains an enigma, a vast, vibrant secret that continues to whisper new truths, just as we think we have mastered the old ones. We are learning that to be wrong is not a failure of intelligence, but a triumph of discovery. It is the signature of a species that refuses to be content with the comfort of a settled narrative. Whether our universe is 13 billion years old or nearly 30, whether it is a singular event or merely the latest breath in an eternal cycle of rebirth, the mission remains unchanged. We must keep looking, keep asking, and keep daring to cross the velvet void in our vessels of steel and light. In the end, perhaps the most startling scientific truth is not the expansion of space or the impossible maturity of infant galaxies, but the fact that we are here at all, microscopic specks of dust that have built machines to stare into the very eye of eternity. The universe may not be what we thought, and as the data suggests, it is likely far weirder than we can ever imagine. But it is our home, and the search for its true nature is the greatest adventure we have ever undertaken. We do not look to find answers that fit our books. We look to find a reality that expands our souls. There are still big surprises out there for us, waiting in the dark, and we have only just begun to see. While the James Webb Space Telescope peers through the eye of a needle to see the heart of ancient galaxies, a new generation of sentinels is preparing to stand watch over the entire sky. We are entering the era of the great surveyors. If Webb is our cosmic microscope, the upcoming Nancy Grace Roman Space Telescope and the Euclid mission are our wide-angle lenses, designed to see not just the individual stars, but the entire forest of the cosmos in a single, breathtaking snapshot. Roman, with a field of view 100 times greater than Hubble, will scan the heavens with a speed and precision that would have taken previous generations a millennium to achieve. These missions are not just looking for more galaxies. They are seeking the final verdict on the Hubble tension. By observing thousands of supernovae through the distorting glass of gravitational lensing, Roman will provide a geometric measure of the universe's expansion that does not rely on the brightness of a single star or the calibration of a local ladder. It will be a cold, unbiased witness to the truth. Within the next few years, these watchers on the horizon will determine if we truly need to tear out the first page of our cosmic history book and begin again. We find ourselves in a rare moment in the human story, a time when our instruments have outpaced our imagination. We are building the tools to measure the infinite, even as the infinite refuses to stay within the lines of our equations. But this is the beauty of the search. We do not build these monuments of glass and gold because we know the answers. We build them because we have the courage to ask the questions. We are ready for the universe to be larger, older, and far more mysterious than we ever dreamed. The wide field is open, the light is reaching us, and the next chapter is about to be written.